Hi, my name is Arham and today I'm really excited to be talking to you about something very interesting. Did you ever wish that the President of the United States was Mr. Bean? Or maybe you just love him so much that you wish that every character in almost every TV show and real life was Mr. Bean. What you saw in front of your screens was not real life, and we'll talk about how we made that possible. But before that, I want to refer back to one of our classes where we first learned about adversarial search, which was a device employed by an AI to beat a human player at a certain game. And now, taking that one step further, what would happen if we pit an AI against an AI? Well, that would give us general adversarial networks, which is the topic of our video. And I'll let Sarah take it forward from here.
Okay, so that was a very good introduction. So now let's get into the details of what general adversarial networks actually are. So GANs are a very new technology. They were introduced in 2015 by Ian Goodfellow. And so what they basically do is that given a set of inputs, they produce new data from the input. So for example, if I give them a data set containing images, so it can, like images of like human faces, it can produce more images of human faces based on the data that we provided. How is it different from other typical machine learning models is that it's not like, oh, it produces an output and then it, compares it to a real life data to check how accurate it is. It's not actually how they do it. They actually put two AIs against each other to not only just see the accuracy of the model, but to make the model even better. So GANs consist of two models, a discriminator and a generator. So the work of a generator, as suggested by the name, is that it's supposed to generate new data sets based on the data that it's given. And the data needs to be it tries that the data is as close to reality as possible. And discriminator tries its best to predict whether the data is real or generated by the generator. So what happens is that in this process of guessing is that the generator gets stronger and stronger in making data sets which are more and more closer to reality, and discriminator gets better and better in predicting or discriminating between the real data and the data that is created by generator. So let's see a small video that tells us about what actually happens between these two models. So let's go.
शुरू में जनरेटर डिस्क्रिमिनेटर को बिल्कुल भी बेवकूफ़ नहीं बना पाता, लेकिन हल्के हल्के करके बहुत सारी बारियों के बाद जनरेटर की क्वालिटी इतनी अच्छी हो जाती है कि डिस्क्रिमिनेटर उसके बनाई हुई चीज़ और एक एक्चुअल रियल लाइफ इनपुट में फ़र्क ही नहीं बता सकता. Now with all that set aside, let's try to figure out where GANs are used in real life. And number one is GANs being used in Photoshop. And they created these things called neural filters that allow for a photo to be manipulated in terms of a person's age, their smile, and they can even colorize black and white images. And all of that happens instantly through the power of GANs. Secondly, we have NVIDIA that focused on providing gamers a fast gaming experience. So for that, what they did, they used GANs to actually learn how to super sample and upscale images without barely any loss in quality. And that's why they created deep learning super sampling. And through that, they now can render their games at a much lower resolution, allowing their graphics card to actually render more beautiful scenes at much higher frame rates and then just upscaling it. And then finally, one thing that NVIDIA again also worked on was data synthesis. Medical field is something of a tricky place where there's not enough data for doctors to actually utilize and create machine learning models for, because there are some diseases where there's not enough people sick enough. So with data synthesis through GANs, these networks can then generate multiple variations of a certain data in a way where it's giving us a wide array of differences and variations. And that then allows us to augment data sets and increase their size to help machine learning models learn all the more better. And I hope all of this gave you a better idea of what an amazing technology GANs are. And I hope to see all of these applied even more broadly across the whole technological spectrum. Thank you so much for listening, and Allah Hafiz.